So you're excited about learning TypeScript and you even shared it with your mom, but then she said that you don't need TypeScript because you have TypeScript at home. And obviously she's right because she's a smart woman, and what she meant is that JavaScript already has types. In JavaScript we have 7 primitive types: string, number, big int, boolean, undefined, symbol, and null. And alongside those primitive types there are also primitive wrapper objects. So what am I talking about? Because, for example, why do we say in TypeScript we say string instead of capital string? And first, this is invalid, of course, but another reason is that this is a primitive wrapper object, and I'm going to show you what it means. So we can also see that the type of these values, if we log them out, so we can say node, and we get back string, number, and boolean. But if you go into node, so I can show you what I mean, here I have an example. First, let's make a string primitive that is going to be Pikachu. And then if we log it out, we can get back Pikachu. So you want to access methods and properties on this string, right? So you want to say, for example, to uppercase. So for this to be possible behind the scenes, JavaScript converts this string primitive to a string object because only those methods are available on that object. So you don't have to think about it, and it makes working with the language much easier. So yeah, so we can say it like this. So this returns the uppercase Pikachu. But if we just look at a string object, which is going to be new string, this is what gets converted by JavaScript. And then you can say string object. And then if I go here at the example, we can get the value of this string object, value of, and then we can get the value. So imagine how tedious this would be if you had to do it yourself. So basically this is what's done for you under the hood. And this is because methods like toUppercase extend the string object. So the reason we don't use primitive wrapper object is because it's more work to get the value out of the object, and we will get unexpected results if we pass an object to something expecting a primitive value, for example. That being said, don't confuse the new string constructor with the string function that does type conversion. So for example, let's say you have a number that's a string. This is usually when you have an input or something. Yeah, and then we can use string, and then we can turn it into a number. So as we've learned, TypeScript doesn't save us at runtime, so we have to put checks in place. As we see here, let me just close this. Yeah, so really, let's, for example, we have a function isString value. We can give it a type string. We can say return. Don't worry, we're going to learn about this later. I just want to show you an example. So we need to have a check in place. We have to say type of value, string, and then we're going to return true or false. So let me just quickly change this. Also, let me change the extension so we can say TypeScript. And not falses. That's a really cool name, right? Yeah, and then we can say isString Pikachu is string 1. And we also get the warning because TypeScript is awesome, and this can save us from these type of errors. So as I said previously, this might look like we're writing more code, but let's look at how this can save us. So for example, I have an example here that is const Pokemon, which is going to be an empty array. Then I'm going to have add Pokemon, I'm going to add the name and the time added. So let's say Pokemon push, name and time added, simple as that. And then we're going to invoke it, add Pokemon. We're going to add Pikachu, and we're going to add new date. So the problem with this is that, let's say, we really haven't typed anything, so we need to really keep a lot of things in our head. So we need to account for, is this function callable? Does the function return anything? So what are the arguments of the function, and what date format does the argument accept? If we look at the implementation of add Pokemon, we don't know what date format we should pass to time added. So right as we've seen here, we just type add Pokemon, and we can say whatever. So this is a name, but we don't really have any information here. It's time added any, which means any type, and this really isn't useful. So you have to open the documentation or whatever and read it from there. But we can really make this more useful thanks to TypeScript, because TypeScript can help us prevent those mistakes in the first place by knowing we are accessing the right properties and passing the right arguments alongside getting great code completion. So in this example, let me just remove this. I'm also going to remove this for now. Yeah, so let's just be explicit. So we can say string, and the time added should be of type date. That's a built-in type. And yeah, this is really awesome. So for example, if I go here to add Pokemon, we can see when we're auto-completing it wants a string. So you can say Pikachu and time added should be date. So for example, you can make a blunder and you can just include date, which isn't correct. It's going to even tell you argument of type string is not assignable to parameter of type date. And this really saves you from debugging, etc., because you can like immediately fix this by using the constructor that it wants. And now TypeScript is happy, and that is really awesome. So if I go here in the post, I explained that in the example, the argument name is of type string and argument time added is of type date, which is just a built-in type, as I already said. So this is extremely useful in dealing with some API because the documentation lives inside your editor. So the date function returns a string, but we have to pass the new date constructor that returns an object. So the type doesn't match, so TypeScript complains that you can't assign string to date. And this is why TypeScript is so beloved and so awesome. And I hope you're starting to get excited about this and all the possibilities that it offers you.